Right, so section 5.5 is on the dot product. Up until now, we have not multiplied vectors together. Okay, we've multiplied a vector times a number, which makes it longer or shorter, but we haven't multiplied a vector and a vector. We've added vectors, we've subtracted them. Okay, now we'll look at multiplication. When we multiply vectors, okay, first thing I just want you to understand is there's two ways to do it. Okay, one way is called a dot product, which is what we're about to go over. The other way is called a cross product, which we are not going over. One reason I can't show you a cross product yet is because cross product is only in 3 dimensions. There's no such thing as 2-dimensional cross product. That doesn't work. So since we're still in 2D, we're never going to see cross product in this class. Okay, but just know if I asked you on a test how many ways can you multiply vectors, there's 2. Dot product, which you're going to learn, and cross product, which you're not. All right, so suppose we have 2 vectors. When we go through a problem, these would all be numbers, like 3i plus 2j and negative 7i minus 5j. Okay, so each vector has a horizontal and vertical component. Okay, so a1, a2, b1, b2, they're all numbers in a real problem. Okay, to find the dot product, okay, very simple formula. All you do is take your 2 horizontal components, a1 and a2, multiply them together. Take your 2 vertical components, b1 and b2, multiply those together, and then add those 2 answers. And that's it. That's a dot product.
So it's just going to give you one number, right?
Yep, that was my next question, is what kind of answer is this? This is a number.
Oh,
Right? Because when you multiply a number times a number, you get a number. A number times a number is a number. And if you add 2 numbers, the answer is a number. Okay, so like 5. Okay, so a dot product, the answer is just a number. All right, so let's try to find the dot product of these 2. Okay, 2i minus 3j and 5i plus 3j. Okay, Zach, what would be the first 2 things I'd multiply together?
2 and 5.
Yep.
So that comes to 10.
Yeah, we'll write 10 in a second. So we got 2 times 5 plus, and can you give me the next 2 things I multiply?
Negative 3 and positive 3.
Negative 3, positive 3. Okay, and if we do that out, we're going to get 10 plus negative 9. So what is the dot product of these 2 vectors? 1. Okay, that's it. That's the dot product. We'll see what you can actually do with this number in a little bit, but for now, just knowing how to find it is that's good. So any questions on v dot w? Okay, and I don't know if I mentioned that, but that is how you pronounce it, v dot w. Okay, when you're talking about vectors, you can't say v times w, because there's 2 ways to times, dot and cross. If you say times, you're not being specific enough. Okay, so this is v dot w. Right, now let's try w dot v. What property do you think I'm checking to see if it works here? What's that property when you switch the order?
Distributive.
No. Nope, not distributive, not associative.
What does it start with?
C?
Commutative.
Okay, so you almost there. So what I'm checking to see is if I switch the order, do I get the same answer? Okay. So now when we do w dot v, it would be what times what? Now it's 5 times 2. W comes first. And then 3 times negative 3. But since multiplication is commutative, and really to do the dot product, okay, that's all we're doing, we get the same answer. 10 plus negative 9. Okay. So the dot product is commutative. If we were to study the cross product, we would learn that it is not. V cross W and W cross V, they come out different. Again, we're not gonna study that. Okay, but the dot product is commutative. Okay, let's find V dot V. Okay, what do you think I would do to do V dot V? Yeah, we're not going to use W for this one. All you need is V. How would I write that?
Times 2 plus negative 3 times negative 3.
Yeah, it's 2 times 2 plus negative 3 times negative 3. You're using the same number. Okay, 2 times 2, negative 3 times negative 3. So what's the dot product of V dot V? 13. 13. Okay, and we'll also try doing the dot product of W dot W. That's going to be 5 times 5 plus 3 times 3. So Dakota, what's W dot W?
34.
34. Yep. Okay, does this look familiar? Anything we've done before? Take this number and square it. Take this number and square it, and then add them together. We normally do one more thing. Yeah, it's almost like finding the length. Okay, when you want to find the length, you do 5 squared plus 3 squared, add them up, but then you'd have to take the square root. We're basically doing everything here except taking the square root. Okay, so dotting a vector with itself, it's almost like finding the length of it, but you don't take the square root. That's the pattern. And that's what I just said. So dotting a vector with itself doesn't give you just the length of the vector. It gives you the length of the vector squared. You didn't take the square root. Okay. Same thing here. When we did W dot W, we got 34. Okay. 34 is not the length. Square root 34 would be the length. Okay. So what we really have is the magnitude squared. All right, we'll practice one in a different notation, not using I's and J's here. Okay, anybody think they can just tell me what the dot product would be there?
It's going to be 2 times 0
Yeah, we can write it out if we want. 2 times 0,
plus
6 times 0.
6 times 0,
0 plus 0 equals 0.
0. Okay, and now is that a number or is that a vector?
It's a number.
That's a number. Okay. That would be different if I did something like this. If I take a vector and I scale it by the number 0, I get that as my answer. Okay, anytime you scale a vector, your answer is a vector. Longer, shorter, or 0. But when you do a dot product, the answer is a number. Okay. Does everyone understand the difference between 0, the number, and 0, the vector? Okay. Dot product, you're always getting numbers. Right, so one thing that does work with the dot product is distributive property. Okay, if you had a vector on the outside, you can do u dot v plus u dot w. Okay, that does work if you wanted to do it. All right, so one of, in fact, the only thing that we're going to use the dot product for is really to find the angle between two vectors. Okay, that's what we can use it for. If you have two vectors and you can get the dot product, that's part of the formula to finding the angle. Okay, there's three things that you need to find the angle between two vectors. First of all, you need the dot product. Okay, second thing you need is the length of u. And the third thing you need is the length of v. Okay, so you need those three things. Okay, so the denominator is the length of u times the length of v. The numerator is the dot product of u and v. Okay, so any question on that formula? Cosine theta equals the dot product over the product of the magnitudes.
That's defined.
That's to find the angle between two vectors. Okay, what I'll do on this first one is I'll draw it out and I'll show you what we're going to find. Okay, does everybody have the formula? Good. All right. Okay, so first I'll just sketch what we're going to find. A sketch is not necessary to do this at all. Okay, I'm purely just showing you what we're going to find. All right, so I've got the vector 4I minus 3j. 4. Okay, I'm just going to sketch it by hand. Okay, that's one. The other one is 2I plus 5j. We are finding this angle right there, the angle between the vectors. I would say if I drew it accurately, it looks like it's maybe a little more than 90, 100, somewhere around there. So as we go through it, we'll see if that's what we get, an angle around, maybe around 100. Okay, questions on what we're finding? All right, so what I'm going to do is just move all this down. All right, so first thing we need is our dot product. Paige, can you set up my arithmetic to find the dot product?
Would it be 4 times 2?
Yeah, 4 times 2.
And then negative 3 times 5.
3 times 5. Okay, so we're going to get 8 minus 15. And 8 minus 15 gives me negative 7. Okay, that's the first thing I need. All right, so I've got the numerator. Now I got to find the length of u and the length of v. All right. Anytime I have to find the length, just so I don't forget, first thing I do is just put the square root symbol in. Okay. And Callie, can you give me my formula for finding the length of u? Careful, you don't want to double 4. You want to think of Pythagorean theorem. We square it. Yeah, so I'll do that next. So 4 squared plus negative 3 squared. Add them up and take the square root. 4 squared is 16. Negative 3 squared is 9. Don't make the mistake of not canceling the negative. You can't. When you square a negative, it's gone. Okay, so that's 16 plus 9. And square root of 25 is 5. Yeah, that's the second thing I need. Length of u. Last thing is length of v. Got 2 squared plus 5 squared. Add them up. Take the square root. That's 4 plus 25. Just leave it, square root 29. Okay, any questions on those 3 things? Okay, last step. Fill them into our formula. So the cosine of your angle equals the dot product divided by the product of the magnitudes. All right, so now my goal is to get theta by itself. I've got this cosine function I want to cancel out. Does anybody remember what function cancels out cosine?
Inverse cosine.
Inverse cosine. Okay. And inverse cosine. Okay, so take the inverse cosine of what's on the right. And that's the angle we're hoping is somewhere around 100 degrees or so. Okay, you can do this in radians or degrees. I prefer degrees, so that's how I'm going to do it. Okay, and type in -7 divided by, I'm just going to put it in parentheses so it doesn't mess up, square root 29. Right, so -7 divided by 5 square root 29, and we got an angle of 105.07 degrees. It's about what we thought. Okay, so that's the angle between those two vectors. Okay, any questions on that? All right. Still copying down. Right, so two special things that can happen is vectors can be perpendicular to each other. Okay? And when two vectors are perpendicular, the word they use is orthogonal. Okay, just what they call it. All that means is that the angle between the vectors is 90 degrees. So if I ask you, are the following vectors orthogonal? I'm asking you, are they perpendicular? Or do they have a 90-degree angle? Okay, and there's actually a very nice shortcut to figure out if two vectors are perpendicular. You don't even have to go through all the work. Okay? And I'll show you why. Okay, what did I just say? If two vectors are orthogonal, that means the angle between them would be what?
90 degrees.
All right, so let's say the angle was 90 degrees. And we had the fraction on the other side. Okay, you'll see in a second. It doesn't matter what this really is. Let's see what the cosine of 90 comes out to. 0. Right, so if your vectors are orthogonal, this entire side is going to come out to 0. Well, what's the only way that a fraction can equal 0?
There's 0 in the denominator.
If the 0, let's try it. So if you take like 5 divided by 0,
Oh, okay. So
Isn't it the other way?
the other way, yeah. So only way a fraction can equal 0 is if the top is 0. Doesn't matter what the bottom is. Bottom doesn't matter at all. Okay, the only way a fraction can equal 0 is if the top equals 0. Okay, now I want you to think back to your formula. What's in the top?
V times it. Oh, wait, which one?
In that formula that said cosine theta equals
The dot product.
the dot product. Okay? The dot product is what was in the top. So basically, if the dot product comes out to 0, that's going to make the top 0. And 0 divided by anything is 0. And if we get 0, that means the angle must be 90. All right, so the shortcut to figure out if two vectors are, that's the symbol for perpendicular. All you have to do is find the dot product. If the dot product is 0, they're perpendicular. Right, so you don't have to find the lengths. Just find the dot product. Okay, so this question is saying is asking if these vectors are perpendicular. Just find the dot product. Right, Ben, can you tell me what would I multiply here to find the dot product?
2 times I. Right?
Well, this all has to be numbers.
So 1.
1. Yeah, so 2 times 1. Yeah,
1 times 2.
and 1 times 2. So what's 2 plus 2? 4. So are these vectors perpendicular? No. All right, we already did the dot product. What could I do to make them perpendicular? Change one thing.
Make either V or W and minus sign.
Yeah, just put a minus sign in anywhere. Okay, if you put a minus sign in here, then it would be negative 2 plus 2. Okay, if you put a minus, it doesn't matter where you put it. If you made any one of these a minus, they would become perpendicular.
So the dot product has to equal 0 for it to be perfect.
Yes, if two vectors are perpendicular, their dot product has to come out to 0. All right, let's, yeah, so that's it. Any questions on the perpendicular? Okay, so it's pretty straightforward. If two vectors are parallel, okay, that's the other special case, there could be 2 different angles between them. Those vectors are parallel, and if you think they're pointing exactly the same way, the angle between them is 0. I didn't draw them on top of each other because you'd have a hard time seeing it. And those vectors are also parallel. So if they point in the same direction or opposite directions, I want to think of it like that. Both situations are parallel. Right, let's take the cosine of 0, just like we did cosine of 90, and let's see if we can get some kind of special trick this time. Right, so let's take the first example. Okay, cosine of 0. Let's see, that comes out to 1. Okay, so we get 1. Well, we don't quite have the same shortcut, but we can come up with something. What's the only way a fraction equals 1? If the top and bottom are the same. Okay? So if the dot product equals the product of the magnitudes, so you do have to find the product of the magnitudes here. But if they come out the same, you get parallel. Or what was the other angle, 180? Let's see what would happen if they were opposite directions. So we get cosine 180. We get negative 1. Okay, what's the only way a fraction could come out to negative 1?
If the top and bottom are the same, but one of them is negative.
Yeah, opposites. Okay, so your 2 vectors are going to be parallel. We could summarize it. 2 vectors are parallel if either the dot product and the product of the magnitudes, in other words, the numerator and the denominator. Okay, so 2 vectors are parallel if the dot product and the product of the magnitudes are either the same. If they're the same, you get 1, or they're opposites. You get negative 1. Same or opposites. Right, so if your numerator was 5 and your denominator was 5, those vectors would be parallel. Okay, the dot product and the product of the magnitudes are the same. If your numerator was 8 and your denominator was -8, those would also be parallel. Okay? It's just the case where they're pointing in the same direction or opposite directions. Okay, but they're still parallel. All right, does everybody have that? All right, let's try one of those. Okay, determine if V and W are parallel. Okay, if you haven't seen that, that's the symbol for parallel to vertical lines. All right, so we've got to find our dot product, length of V, length of W. Okay, so my dot product is going to be 4 times 20. Jacob, what's 4 times 20?
80.
Yep, 80. And -5 times -25 is 125. Okay, when we add those up, what's 80 plus 125?
205.
205. So now, the top is 205. If the bottom comes out to 205, we're parallel. If the bottom comes out to -205, we're parallel. If it comes out to anything else, we're not parallel. All right, now we'll find length of V. Okay, Brandon, what's the first thing that I square to find the length of V?
4 squared.
4 squared. Next thing?
-5 squared.
Good, -5 squared. That's going to give me 16 plus 25. Okay. So I don't know if they're parallel yet. I'm still got to find W. Hey, Charlie, first thing I square to get length of W?
20.
And 20 squared is 400. Then I'm going to square
20, -25.
-25. That's 625. That's the square root of 1,025. Okay, so let's see what the square root of 41 times the square root of 1,025 is. Square root of 41. That's the length of V. Now length of W. Square root 1,025. 205. So my numerator is 205, my denominator is 205. They came out the same.
So once you find the square root, you just multiply.
Mm-hmm.
What did you just do?
Yeah.
I just multiplied these two together. I'm just using my formula. Okay, I just found this. Okay, that came out to 205. What did my dot product come out to?
205.
205. Yep. I think we used U and W, V. It doesn't matter what letters you use. Since the top and the bottom come out the same, what does that mean?
It's 1.
If the dot product and the product of the magnitudes are the same or opposite, we're parallel. Okay. Two vectors are parallel if the top and the bottom come out the same. And that's exactly what just happened. Top was 205, bottom was 205. Okay. So determine, the answer is yes. Yes, they are parallel. Okay, so any question on how we figure out if two vectors are perpendicular or parallel? All right. All right, last problem for today.
Yes, sir.
All right, so in this problem, okay, we have a plane maintaining an airspeed of 500 miles an hour south. Okay, first, does everyone understand the difference between airspeed and ground speed of a plane? What that means?
No.
All right, so, all right, here's an example. If you're driving down the highway, okay, let's say there's no wind outside, perfectly calm day, and you're going 60 miles an hour, and you stick your hand out the window. It's going to feel like the air is hitting your hand at 60 miles an hour. Right? Now, let's say a different day, you're driving down the highway, and you're driving into a wind that's 40 miles an hour blowing at you, and you're going 60 into the wind, and you put your hand out the window. How's it going to feel like the air is hitting your hand then?
100 miles an hour?
It's going to feel like it's hitting you at 100. Because if you were just standing still on the highway, it would feel like it's 40, because the wind's blowing at you at 40. And if you're driving even faster into the wind, it's going to feel faster. Okay, that's the difference between airspeed and ground speed. Okay? So if you think of it like the ground speed of a plane would be if somebody took a radar gun and pointed it at the plane and got the speed. Right? That's how fast it would be moving. But the airspeed takes into account the wind. Okay? Just like if somebody put a radar gun on your hand, even if the wind is hitting you at 100 miles an hour, you're only going forward at 60. It's just there's a wind blowing. Okay? So that's the difference between airspeed and ground speed. Okay, so this plane is trying to fly 500 miles an hour directly south, but there's a wind blowing at 80 miles an hour northeast. Okay, I wouldn't give you a random direction. Okay, I would always say the wind is blowing like northeast, northwest, southeast, or southwest. Okay, because it makes the angle easy to figure out. Okay, I want to find the speed and direction of the aircraft relative to the ground.
Wait, it's blowing northeast.
Yep, the wind is blowing northeast. Sometimes you might hear it like on the news, there's a wind from the southwest. If the wind is blowing from the southwest, it means it's going towards the northeast. I think it's confusing to say it that way. Like sometimes you might hear, oh, we got winds coming out of the north today. Well, that means they're blowing south. Right, so that's our problem. All right, the first thing I'm going to do is draw, not exactly to scale, but I'm just going to try to get a picture of the plane, a vector for it, and then a vector for my jet stream. Okay, so the plane is flying 500 miles an hour south. Okay, does everybody have the word problem? All right. So let's draw my plane, 500 miles an hour south. I'm going to make that red. Okay, that's the direction the plane wants to go, south. But there's a wind blowing northeast. Okay, not quite 500 mile an hour wind, so I'm not going to make it as long. It's only an 80 mile an hour wind. Only 80 miles an hour. But I'm going to make it a little shorter. And it's blowing exactly between north and east. So what do you think that angle would be?
45.
Yeah, it's going to be a 45-degree angle. That's why I did that. It makes it a little easier. Okay, let's make that green. Okay, so any questions so far? All right, so what I'm going to do, just to visually make it a little simpler, is I'm going to put the wind right on the end of the plane, and I'm going to draw this vector. That's the direction the plane is really going to go in, okay, in black. If the pilot doesn't make any adjustments, he's going to be blown off course, and instead of going south, first of all, he's flying into the wind a little bit, because the wind is blowing northeast, he's trying to fly south, so it's going to slow him down. and it's going to blow him off to the east. Okay, so this is my velocity vector. We'll call that for the plane. That's for the wind. And I'll call this one plane actual. Okay, that's the actual direction the plane is going to go in. Okay, any questions so far? All right, so now my goal, what I want to do is turn this and that into numbers. Okay, I want to get away from the picture and just write everything in terms of numbers. Okay, let's start with V sub p. Okay, the plane is going directly south. So does it have V sub p? Does it have any left and right direction to it? No. 0I. There's no horizontal for V sub p. Now it's 500, but it's down. So how do you think I would represent negative 500? Okay. There's your velocity vector for the plane. It's negative 500j. Okay. Now I need my velocity vector for the wind. Okay, and this one, what I'll do is I'll draw it off to the side so we can just kind of look at it. What angle did we say the wind is blowing at?
45.
It's a 45-degree angle. And what is the wind actually blowing? How fast? 80 miles per hour. Okay, so it's blowing east and it's blowing north, and together it's 80 miles an hour northeast. Okay, what trig function could I use to find just the horizontal component of the wind, the x component? Cosine. Basically, I'm just finding the lengths of the sides in this 2 triangle. Okay? So we get cosine 45 equals adjacent over hypotenuse. Okay? And how would I get x by itself? Multiply by 80. That's the I component, which I'm going to write down, of the wind. 80 cosine 45. So 80 cosine 45. So if the pilot does nothing to correct that wind, he's going to be blown off course 56 miles to the east every hour. Okay, so every hour he's going to be 56 more miles off course. So 56.57. Okay, but that's just how far off course east he's going to be blown. The north component of the wind is going to slow him down because he's trying to fly south. The wind is blowing north. Okay, what trig function would I use to find y? Sine. Okay, what would be my fraction? Sine equals what's opposite? What's hypotenuse? Y over 80. Okay, solve it exactly the same way we just did for x. That's the north component of the wind. Okay, that's how much it's slowing him down. You can type it in, but it actually comes out exactly the same. Just a coincidence. Okay, so 80 sine 45 is 56.57 J. Okay, so now we've got our velocity vector for the plane, we've got our velocity vector for the wind. What am I really doing when I attach that green vector onto the end of the red one? We did this very first day. We're adding, that's it. We're adding these 2 vectors together. Okay. So now to find the actual vector for the plane, just add VP and VW. Okay. So that the plane's actual vector is the way it wants to go, plus the way the wind is going to affect it. All right, so VP, we've got negative 500J. This time there's no I. And then VW, 56.57I. Okay, are there any like terms I can combine there? Yeah, just the J's. So it's 56.57I. And now remember, he wanted to fly at negative 500 miles an hour south, but this wind is slowing him down. Plus 56.57. So it's negative 443.43. And that is that line in black. This vector models the actual direction and the actual speed the pilot is going to go if he doesn't make any adjustments. What else did they want? Anything else?
Can we go back down real quick?
Yeah. I'm not gonna find the direction. I'm gonna stop at this. I'm just gonna find the speed. Okay, so the speed, is that the magnitude of this vector, or is it the direction? It's the magnitude. Okay, so if we want the speed, our last step, find the magnitude of that vector. Okay? This is, if you were standing on the ground with a radar gun and pointed at the plane, this is how fast it would say the plane's moving. Okay? It's not how fast if you were on the plane and you stuck your hand out the window. It's not how fast the wind is hitting your hand. Okay? That's different. It's how fast a radar gun is, the plane is going. Okay? All right, so we do 56.57. Squared plus negative 443.43 squared. Okay, so we'll just type that in and see how fast the ground speed, radar gun speed of the plane is. Okay. All right, so just type it all in at once. Square root 56.57. Plus negative, you know what, since the negative is going to cancel out to simplify it, I'm just going to type it like this. Okay, the negative is going to go away anyway. So if you were standing on the ground with a radar gun, it would say the plane is going 447 miles an hour. Okay? Even though the pilot thinks his airspeed is faster, he's flying into a wind. So that complicates it. Question on that last step?
No, my calculator, I typed in the same thing, gave me 439.
Unless I typed it wrong?
No, I probably did.
I could show you if you, on your calculator. If you're not sure how to type it in, I'll show you. All right, so on the test on Friday, okay, there will be a bonus. It'll either be something about a plane being blown off course, or it'll be about a weight hanging. I think the plane one is a little easier than the weight, so we'll see. Okay, but again, like the weight one, if you didn't get this one right away, it does take a little practice. But there's no systems of equations here. Okay, that with the weight one, you had to do that from Algebra 1. You don't have to do that here. So. All right, so the homework, okay, tonight it's on 352. It's 7 to 17 odd. Make sure you read the directions. It says each question has 3 parts. I think it says find the dot product, find the angle, and then are they parallel, perpendicular. So really all the parts are related. Okay? And then number 25.